Okay, so in this video I'm going to have a look at the 2020 Higher Level Maths Paper 1, this is the Leaving Cert, and we're going to have a look at question 1. So the first question here is question A, and it's f of x is equal to x squared plus 5x plus p, where x is an element of R. P is somewhere between minus 3 and 8 inclusive, and p is an integer. Find the value of p for which x plus 3 is a factor of f of x. Well, if x plus 3 is a factor, that just means that x is equal to minus 3 is a root by the factor theorem. So if x is equal to minus 3 is a root, all we've got to do is substitute it into our original function. So we've got minus 3, square it, plus 5 times minus 3 plus p, and that should be equal to 0 because minus 3 is a root. So if we do this, we get 3 3s 9 minus 3 5s 15 plus p is equal to 0. That'll give us minus 6 plus p is equal to 0. And finally, that'll give us p is equal to 6. So that's it for part 1. Part A1, let's have a look at part 2. Find the value of p for which f of x has roots which differ by 3. So let's just make up two roots. We'll call them m and m plus 3. These are our two roots of our new function. So we know that we can form a quadratic by using the equation x squared minus the sum of the roots times x plus the product of the roots. So let's do that. We have x squared minus the sum of the roots is going to be m plus 3 times x, and then we've got the product of the roots is going to be m times m plus 3. So let's see, we have x squared minus 2m plus 3, m plus m, 2m, and here we have m squared plus 3m. Now remember our original function was x squared plus 5x plus p. It was our original function f of x. Okay, so what we have to do is find a value of p here. So we got to find a value of p here. This is going to be our p here. So find a value of p for which f of x has roots which differ by 3. Well, this new function here, this new function here has roots which differ by 3. This was our original function. But we've got to keep these two bits here the same. This is the part that's going to differ here. So let's see what p could be. Well, this part here, the minus 2m plus 3, has to be equal to 5. So let's just write that down. So our minus 2m plus 3 would have to be equal to plus 5. So let's work out what m would be. That's minus 2m minus 3 is equal to 5. That'll give us minus 2m is equal to 8. That'll give us an m here equal to minus 4. So if m is equal to minus 4, remember we want to work out what p is here. So p we know is going to be equal to this bit here. So p is going to be equal to, p is just going to be equal to m squared plus 3m. Now we've worked out what m should be. So p is going to be equal to minus 4 squared plus 3 times minus 4. That'll give us p is equal to 4 squared 16 minus 3 fours 12. That'll finally give us p is equal to 4. So this is our answer here. This is our answer. We were asked to find a value of p for which f of x has roots which differ by 3. Let's just double check that. Just do that here. Our original function was x squared plus 5x plus p. Well, our new p, if you like, is going to be 4. And the question just says, find a value of p for which f of x has roots which differ by 3. So we want to find the roots of this particular function. This is just a check. You don't necessarily have to do this. You can if you have time in the exam. So let's see, this will give us x4 can be 4 times 1 plus that will give us x being equal to minus 4 and minus 1. Well, that'll work. Minus 4 and minus 1 do differ by 3, which is what we were asked to do up here. The two roots have to differ by 3. Minus 4 and minus 1 differ by 3. Okay, so that's it. Find the two values of p for which the graph of f of x will not cross the x-axis. Will not cross the x-axis. That means we will have non-real roots. And for non-real roots, the discriminant is going to have to be less than 0. So remember, our discriminant is b squared minus 4ac. We want that to be less than 0. Now our function was, what was it, x squared plus 5x plus p. This is our function here. We want b here, so I'll just write down a, b, and c. A is going to be equal to 1, b is going to be equal to 5, and c is going to be equal to p. So let's substitute these in here. So b is 5, so we got 5 squared, minus 4 times a, which is 1. C is going to be p. We want that to be less than 0. So let's see, that gives us 5 5's 25 minus 4p less than 0. So that will give us minus 4p less than minus 25. Finally, that gives us p greater than 25 over 4. So remember to switch around the inequality sign there because we're dividing by a negative number. Now remember from the original question here, p here has, let me see, what does it say? P has to be between minus 3 and 8, and p is going to be an integer, so it's a whole number. And it has to be somewhere between minus 3 and 8, including 8, and including minus 3. So our answer here is x has to be greater than 6 1/4, 25 over 4. So that means then that p will have to be equal to 7 and 8. Remember, it says in the question here, find the two values of p. Find the two values of p. So we know that p has to be greater than 6 1/4, and p is an integer. So it has to be 7 and 8. Remember, p has to be between minus 3 and 8 inclusive. Part B then, we have find the range of values of x for which 2x, the modulus of 2x plus 5 minus 1 is less than or equal to 0. Okay, so this should be reasonably straightforward. Let's see, we have 2x plus 5 minus 1. We want that to be less than or equal to 0. So what we can do here is, first of all, get rid of that minus 1. So I'm just going to bring that over to the other side. And next thing I'm going to do is square both sides. There are a couple of ways of doing this, but you can square both sides is probably the best thing to do. So I'm just going to take the entire left-hand side, square it, the entire right-hand side, square it. So if I square the left-hand side, I'll get 2 2's 4, x squared, 2 5's 10, double it, so it's going to be plus 20x plus 5 squared is 25. Square the right-hand side, we'll just get 1. That'll give us 4x squared plus 20x plus 24 is less than or equal to 0. Bring the 1 over to the other side. Okay, I can see here that I can divide across by 4. 4 will divide into all 4 terms. So we end up with x squared plus 5x plus 4 6 is 24, and 4 into 0 is just 0. Next thing I'm going to do to solve these things, you just let x squared plus 5x plus 6 equal to 0 first, because you want to find where the function cuts the x-axis. You want to find the roots first. So that'll just give us x times x, 6, and we want a 5, so it's going to be 3 times 2, plus times plus. It'll give us x is equal to minus 3 and minus 2. So because this was an inequality, remember this is what we want to solve here. What you've got to do is draw a sketch of this graph, so of this function. So we're going to draw an x and a y axis, and we've got minus 3 and minus 2. So let's say it's going to look something like this. Okay, so we have our two roots here. Now remember, our two roots are minus 3 and minus 2. This is not the scale, but it's just a rough sketch. So minus 3 to minus 2. So what do we want to solve? We want to solve this function up here, this inequality up here. So we know that we want our y value, this is our y value here, to be less than or equal to 0. So where on this graph are our y values less than or equal to 0? Well, they're equal to 0 here at minus 3 and minus 2. They're less, all these points down here have y values less than 0. The question says what are the x values that will give us these y values? Well, it's going to be all of these x values in here, including the minus 3 and the minus 2, because it's less than or equal to. So our answer is going to be x has to be bigger than or equal to minus 3, less than or equal to minus 2. So that's our final solution there. Okay, so that's it for this video. Any questions, just ask down below.